Alright, so as we go for order of operations here and the things we need to do, we're also going to look at the fractions that make up decimals. But I've been trying to point out the fractions as we come across. So if I have a fraction, we want to remember that this symbol can mean a fraction as something cut into 4 parts, and I have 3 of those parts, but the symbol also means division. So I can convert a fraction to a decimal by doing the division that it suggests. And so this would be 3 divided by 4. It looks like I'm going to need to borrow some zeros here, because 4 can't go into 3, but it goes into 40, or 30. It goes into 30 7 times. 7 times 4 is 28. Subtract, I get 2. Well, I'm not done yet, right? We don't deal with remainders anymore. I keep grabbing zeros. So bring this 0 down, and 4 goes into 20 5 times. 5 times 4 is 20. I've got no remainder, so I'm done. And so the fraction 3/4 is equal to 0.75. Let's look at another fraction here. 2/5. Well, we'll turn this into a division. And I'm taking 2 and I'm dividing it by 5. Keep my decimal point here. 5 can't go into 2, so I'll grab an extra 0. And 5 goes into 24 times. 4 times 5 is 20. I have no remainder, so I'm done. And so 2/5 is equal to 4/10. So let's do a negative one. So I have the fraction negative 3/8. I'll turn that into a division, and I'll keep my negative sign, I guess, outside with the 8. The nice thing about the fractions is the negative can either be upstairs or downstairs when we need to use it. So I'll put it out here. And so I have the 3.0. Eight goes into 30 3 times. I'll keep my decimal point lined up. 3 times 8 is 24. Subtract. Bring down a 0. It'll go 7 times into that. 7 times 8 is 56. Subtract. Bring down another 0. As long as I need them, they're there. And 8 goes into 45 times. 5 times 8 is 40. And I'm done. Well, a positive number divided by a negative number is negative. So negative 3/8 is equal to negative 0.375. And yeah, it's going to be negative because it was a negative fraction. We should get a negative fraction. Well, there are certain fractions that will give us a problem. Let's look at one of those. 5/6. It's not a big problem, but we'll see it when we do this division. So I'm going to have 5 divided by 6. Again, I'll keep my decimal place and grab zeros as I need them. So 6 goes into 50 8 times. 8 times 6 is 48. Subtract. Grab another 0. 6 goes into 20 twice. 2 times 6 is 12. Subtract. No. It's bigger. What did I do wrong? Well, I'm going to get a number bigger than 6. I can actually go one more here. I can go 3 times. 3 times 6 is 18. Subtract, and I get 20. Let's do it one more time. 6 goes into 23 times. 3 times 6 is 18. I get a 2. If I borrow another 0, notice I keep getting 20s. This is never going to end now. And I'll keep getting 3s. And this is called a repeating decimal. And so what we write repeating decimals as is we take the part that repeats and we put a bar over it to say that this decimal is going to repeat forever, the 3 part. And there are certain fractions that just cannot be written as decimals without them repeating. Now, if we have a mixed number, we have the whole part and we have the fractional part. Well, we know in the decimal, this is going to give me everything to the right of the decimal place, and this is going to give me everything to the left. So we'll keep the 3 over here, and we'll focus on the 5/16. So that's saying 5 divided by 16. So I'll keep my decimal place, and I'll get zeros as I need them. So 16 goes into 5 3 times. 3 times 16 is 8. Carry my 1, 48. So I get 2. I'll bring down a 0, because I can always keep bringing down zeros until I run out or I see something that repeats. 16 goes into 20 once. So I'll bring down another 0. Now 16 goes into 40 twice. 2 times 16 is 32. I'll subtract, and I'll bring down one more 0. Well, 5 times 16 is 80, and I'm done. So the decimal part is 0.3125, so I'll add that. And so I'm able to convert a mixed number into a decimal. Now there are some other ways that we can write decimals from fractions that use some nice tricks. So 3/5, instead of dividing it, I can say, hey, wait a minute. Decimals are always some fraction of 10. So it'd be nice if I could turn this into a 10. Well, that'd be great if I multiplied it by 2. But if I just multiply the denominator by 2, I'm going to change the value of this. So I want to multiply the whole thing by 1, because that doesn't change the value. It just changes how it looks. So I'll multiply across the top, I get 6/10. Well, we know that I can write 6/10 immediately in decimal form. Let's look at another one. We'll do 3/50. Well, it'd be nice if I could have some power and 10 in the bottom here. It'd be nice to get this up to 100. So I'll do the same thing. I'll multiply by 2 over 2. And I get 6/100, which in decimal form is like this. Now, if we want to compare a fraction to a decimal, we take 0.125. We want to compare it to 1/4. Well, we'll divide out 1/4. So I'll bring my decimal up above. 4 goes into that twice. Bring down an extra 0. So we can always bring down extra zeros. And so 1/4 is equal to 0.25. And so 1/4 is bigger than 0.125. Because this has 2 in the hundredths, or in the tenths place, and this only has 1 in the tenths place. And decimals follow the same order of operations that we had with whole numbers. All numbers and integers have the same order of operations. So we'll have our PEMDAS, and we work our way down. So if I have 897.8 divided by 100 times 10. Well, I have a division by 100, so that's going to move the decimal place over twice. 8.978 to the left times 10. Now I have a multiplication by 10, so that's going to move my decimal place to the right. Let's look at some more order of operations. If I have negative 8 and 69 hundredths times 3.2 minus 1.8, well, I've got to do parentheses first. So 3.2 minus 1.8 is 6, carry my 1. 24 plus 1 is 25. 1 times 2, 1 times 3. Oh, I'm multiplying. I don't want to multiply, I want to subtract. I was getting ready for the big multiplication at the end here. Well, let's subtract. I'm going to need to borrow 1. 12 minus 8 is 4. And 2 minus 1 is 1. So we get 1.4. So that's what's inside my parentheses. Now here comes the big multiplication. So I'm going to have a negative times a positive, so my answer is going to be negative. So 4 times 9 is 6, carry my 3. 4 times 6 is 24, plus 3 is 27. 4 times 8 is 32, plus 2, 9. And now multiplying by 1, and copy those, and add. It's 10, 11, carry my 1, 12. Now I have to figure out how many decimal places I had in my factors. 1, 2, 3. So 1, 2, 3. And so I have negative 12.166. All right, let's look at a fraction representation of order of operations. And let's throw in an exponent and a division by 10. All over dividing by 0.02. So order of operations we have to do upstairs, and we'll do our power first. So this is saying 1.2 times 1.2. So 4, 2, 2, 1. That's 144. And I had 2 decimal places. So I'm going to rewrite everything, like writing out each step. Now I have a division upstairs, so it's going to take place before the subtraction. And I'm dividing by 10, so I'm going to move the decimal place over 1 to the left. It's 20.06 minus 0.144 divided by 0.02. Now, fraction bars are like having parentheses. So I'm going to do the subtraction upstairs. And I'm going to need an extra 0 here. So I'll borrow 1. It's going to give me a 6. 4 from 5 is 1. I'm going to have to borrow 1 all the way over from here. So 10 minus 1 is 9. 0, or no, this is a 1. No, this is a 0, because I moved over 0.44, so 9 and 1. So 19.916. So that's my upstairs. And now I'm going to divide by 0.02. So I'll go to my long division. And I'll have to move my decimal place over 2 here. Means I have to move it over 2 here. So 2 goes into 19 9 times. Subtract. Let me get myself some more space here. 2 goes into 19 9 times. Did I move this? Yeah. And so 18, subtract, bring down the 1. 2 goes into 11 5 times. So it'll be 10. Now bring down the 6. 2 goes into that 8. And so 995.8 is our answer. Order of operations stays the same. You just have to do some side work to keep it clean. All right. We've been talking about areas of rectangles where we had length times the width. But if we cut a rectangle in half by using the diagonal, length times the width, well, the area of that triangle, because we cut the rectangle in half, is going to be 1/2 the length times the width. And it turns out that no matter the shape of my triangle, I can get its height and its base. And this will give us the same thing as 1/2 the length and the width. So the height and the base are the things we focus on. So the area of a triangle is 1/2 the base times the height. So if I make a very fancy triangle here, instead of drawing it freehand, and I know its height, we'll say it's 2.1 meters, and its base is 7 meters. Then in my area, it's going to be 1/2 7 meters times 2.1 meters. Now, we can rewrite 1/2 as 0.5. So let's do my multiplication. 7 times 0.5 is 35, but there's one decimal place. So I'm going to get 3.5 meters times 2.1 meters. So I'll do 3.5 times 2.1. 1 times 5 is 5. 1 times 3 is 3. 2 times 5 is 0. Carry my 1. 5, 3, 7. And now I count up my decimal places. There were 2. And so the area is 7.35 meters squared. And so decimals are useful when we start measuring things in the real world. We rarely get whole numbers. We tend to get fractional parts of them. And decimals make manipulating them easy. So as we continue our study of decimals, we're going to put them into equations next. And that'll be in the next video. If I can stop this one. Maybe I could just keep, no, I'll stop it.